a few days ago, so they're still going to come back and paint over a patched up hole down there, but I can't really see it anyway. But so anyway, kitchen's looking a lot better. I've got some updates about the materials I'm ordering. I'm just making some instant coffee because I'm watching some snooker on the internet. So anyway, I thought I'd show you my kitchen now that I've got that sorted out. Turn this big light out and I'll show you what I've found out. There's a bit of good news actually. I'm trying to shut this door behind me. Hang on. Kitchen gets very cold. Right, so you remember that choke I wound, that big transformer that with the 2 coils I wound for it? Right, I'll show you what I mean. That thing over there, remember I wound 2 choke coils on there. I've actually swapped them out. So the coils that were on that choke are no longer on the choke. Guess where they are? Guess where those 2 coils that were on there are? Because these are the ones that were on, guess what? My generator. Oh yeah, I swapped them out, swapped them over. So the 2 coils that were on the choke are now here. Right, and guess what? I effectively doubled my output current for the same input current. That's good news, isn't it? Anyway, considering that the output voltage, this is just a quick update, considering my output voltage on the supercapacitors is up here is at 8.44 volts right now. Normally it wouldn't be showing any milliamps, it would be saying 0 milliamps, so it actually does do that occasionally, look. But it's actually showing, keeps going off, but it's because it's charging supercapacitors first. It just keeps coming on every now and then. Every time I move the camera away it disappears for some reason. But anyway, the choke coils, I put them on my generator, and for because we're at 8.47 volts, I'm actually above 100 milliamp. Normally I'll be about 70 milliamps. So earlier when I first switched it on, the supercapacitor was fully discharged, and for the first time I actually saw 200 milliamps on that meter. But you won't see it at the moment because they're partially charged up, but I'm getting a much better I am getting a much better output, because I'm getting output from all these coils now, because these are the 2 coils that were down there before, which I've now put on the choke instead. They were actually thin wire, so they didn't have the current capability. But these 2 coils which I've put on there now, I've got thicker wire, and the thicker wire produces a better current output, more current and less voltage obviously. I'm actually getting decent voltages out of here anyway, so if I take the load off it usually goes up to 50 volts on the oscilloscope. I don't know if I can show you that. Let me just take this clip off this wire a minute. Right, oh, it's still going on it. Hang on a minute. It's got up to 62.4 volts right now, 24 RMS. It's still clipping on the scope because of the, well actually I'm not sure why it's clipping at the moment. There's something clipping it, I don't know what it is. I'll have to figure that out. I've probably got a bad diode somewhere, I don't know. Bridge rectifier. Oh, I've got some capacitors. It might be, I think I know what it is. There's 2 capacitors, electrolytics, on the back of this bridge rectifier board, and I think they're rated at 50 volts, so if you try to put more than 50 volts into 50 volt capacitors, the electrolytics will start to short out and basically cause that clipping effect. So that could be what it is. yeah, I'll probably need to swap them capacitors out and put 100-volt ones in there at some point. But I've been fiddling about with this, and as I was saying in the previous video, I've ordered some ferrite core material, and I was talking to a friend of mine in America. I won't give personal details because I don't know if he wants me to do, but well, I suppose I can mention that he's called Magnetron. He's on the internet, and friend of us, Greece, because I'm not giving you his name, am I? It's just his handle on YouTube. Anyway, he's going to send me some nanocrystalline core material from a transformer. So he's going to post that to me, and the nanocrystalline has 3 times the amount of gain, much less lossy than steel laminations. So that's going to hopefully arrive at some point. I'm hoping that will be probably before Christmas. You never know. We'll see if it might be a nice Christmas present. So it's basically made up of these thin wafers. Well, not wafers. It's made up of like a laminate material that you can buy on a roll actually normally. And this material, it's all stuck together to form the core of a transformer. Well, what I'm going to do is I'm going to strip the core material, peel it off layer by layer, take this nanocrystalline material off, and then I'm going to form my own core assembly for these coils, using some of that, because it'll be much more efficient. If there's enough material, I might even make some corners with it, because that would be more efficient. I'd have even less loss on these corners, because there is a bit of loss on these corners still. So we've got some interesting things to be coming up in the next few months. I'll say months, because it's not going to be weeks, I don't think, at this time. Christmas come in. The postal service is going to be totally chock-a-block, I suppose, because of the Christmas holidays. Most people are not going to be able to go to their families because of the lockdown, well, because of isolation and all, you know, social distance nonsense. So a lot of people are going to be a bit alone this Christmas, which, well, I'm not sure if it's going to be if people are going to abide by the rules, because personally I think it's wrong that people should not be allowed to spend Christmas with each other. That's totally wrong. I mean, we have a right to take our own risks and whatever, but anyway, whatever. I just suspect there's going to be more postal mail, and which is going to put things down a bit, so it's going to take a while for things to arrive. That's my anticipation. So anyway, as I say, it's I put these 2 other coils on at the bottom there. And I'm actually getting usable energy from them now, because before there wasn't usable energy because of the impedance of the coils that were in there before. They were thin 30 SWG wire that was on one of them, and the voltage was it was high voltage, but it was low current, and it wasn't able to do any real work. Well, now I've got some decent coils on there, so I'm actually able to produce more current output, even when the device is slightly untuned. Mind you, I have been fiddling about with it. I've messed up the input current, because I'm actually at 111 milliamps on the input at the moment, which is not good, because it's because I messed up with these. I rewired some of this on here. I was changing the capacitor values. Oh look, my choke fell off as well. I've messed up some of this. I need to swap out some of the capacitors, and I've actually found something interesting about these electrolytics. These 2 electrolytics, I wired them back to back for AC, so the 2 neutral stripes are pointing towards each other, so I can put AC through them now instead of just DC, because these are actually polarized ones, so I had to put them back to back so I could use them for AC. Anyway, I had some interesting effects when I took these 2 capacitors out and stuck a metal film in. I stuck the 1 microfarad metal film in here. My input current shoots through the roof. which is weird because these two are actually 33 microfarad each, which is divided by 2, that would be about 15, 16 microfarad. So they're actually higher value, but because they're electrolytic, they have a different effect on the circuit, and my input current goes down. So it's weird. That just goes to show you the difference that you get between metal film capacitors, which are these brown things. So you get such a difference between these things and electrolytics. You won't believe the difference you get, but it's surprising. It makes a difference. So it just what I'm saying is it's important that you choose different values and different types of capacitor to find the best value. I haven't tried polystyrene in this yet. I haven't really got any high value polystyrenes, but yeah, that's another thing I would like to try. I would like to try polystyrene capacitors. I've got a few, but I am not sure if I've got any high enough value, because a lot of the ones I've got are in the picofarad range. I really need to get a few more in the I need to get some pretty chunky polystyrenes to test with, really, in the microfarad ranges, which is not easy because most of them tend to be in the nanofarad ranges. Yeah, as I say, I'll be taking a break, but we have got some interesting things in the pipe coming, and I am seeing much more output current, and I'm really happy about that, because now it's more consistently at 100 milliamps right now. I haven't got the digital meter on, but let's put the digital meter on. See if I can. Oops. Let's see if I can see what it says on here. It's much better current. Look at that. I thought I broke my thing again. So 106 milliamps even now, and even though our output voltage is already at 9 volts. I mean, according to my meter down here, we're at 10, but there's a voltage drop across the wire all the way up to these, so we will see a drop of voltage. But look at that, still 3 milliamps, 30 milliamps, I mean 30 milliamps is getting up there still. So 9 volts. Normally when I'm at 9 volts up there, I'm not seeing any current on that meter at all. It's normally stuck at naught. And the current down at the bottom down here would be around 40, 50, around 60 milliamps. But I'm actually doing a lot better now. So anyway, yeah, what else is there? Can't think really. Anyway, as I say, I've got the materials ordered from China, so that should be probably hoping for that in December, maybe get it in January. I don't know yet, but we are definitely making some improvements. Yeah. Anyway, so that's it. I can't think of anything else. If there's anything else, I'll stick it in the description of this live stream. Right, see you later, alligator.